Hello everyone, welcome back to the third session of this field effect transistor. In the last two sessions, we saw the basics of FET, the classifications of FET, the construction of N-channel JFET and the working of N-channel JFET. I also told you some of the important questions which is most frequently asked in the previous year question papers. So, adhe thara questions na keltare, you can easily answer. So, in this particular session, I will be dealing with the characteristics of N-channel JFET, which is also very important topic in this particular chapter and which is most frequently used, which is most frequently asked in the question paper. So, let us first try to understand what is this characteristics. Why this characteristics is important. Characteristics andre enu alla. Characteristics is nothing but the behavior of that particular device when we are going to apply some external voltage. So how that device will be behaving with different voltages. Adanne ನಾವು characteristics ಅಂತ ಕರಿತೀವಿ. Why it is important? Whenever I need to use that particular device in any of the applications. Applications ಅಂತ ಬಂದಾಗ I am going to use that particular device in many of the circuits. So whenever I want to use that particular device in any of the circuits, first I need to understand how that device will be behaving for different voltage conditions. So ee characteristics artha madkondrene I can easily use that particular device in different applications. So let's get started with this particular session, that is characteristics of N-channel JFET. So I am considering only the N-channel and here in this characteristics, I will be having two characteristics. One is the drain characteristics, the other one is transfer characteristics. There are two type of characteristics what we have to understand in this particular N-channel JFET. So what is this drain characteristics? Drain characteristics is nothing but the set of curves which gives the relationship between the drain current ID and the drain to source voltage VDS, keeping the gate to source voltage constant. It is nothing but the set of curves which gives the relationship between the drain current ID and the drain to source voltage VDS, keeping the gate to source voltage constant. This constant na ee thara barute. What is this transfer characteristics? Again, transfer characteristics is nothing but a set of curves which gives the relationship between the drain current ID and the gate to source voltage VGS, keeping the drain to source voltage constant. So these are nothing but a set of curves which gives the relationship between the other parameters. So ee characteristics correct artha adre I can use that particular device in any of the applications whatever we want. So let us first understand what is the drain characteristics with the help of a circuit diagram which is used in order to draw the characteristics curve. So here I am using an N-channel JFET agirodrinda let me draw a N-channel symbol. So this is an N-channel. Here we will be using a voltage which will be called as RG, that is the gate resistance ಅಂತ ಹೇಳ್ಬೋದು, which is connected in the reverse biasing condition. This is the negative terminal and this is the positive terminal, and this is the gate terminal, drain, source. Here the drain again will be connected through a resistor RD. Here we will be having a source which is connected in this manner, which will be called as VDD, and this will be called as VGG. The voltage what I am going to measure between the gate and the source will be VGS. The voltage what we are going to measure between the drain to source is VDS, and here the current will be named as ID. So this is the circuit what we are going to use in order to understand the characteristics of N-channel JFET. Let us first try to understand the drain characteristics. As I already told you, drain characteristics is nothing but a set of curves which gives the relationship between the drain current ID and the drain to source voltage VDS, keeping VGS constant. How to keep this VGS constant, or how to vary this VDS and write down the values of ID ಅಂತ ಹೇಳಿದ್ರೆ, here VGS, VDS, ID are nothing but the meters. VGS and VDS are the voltmeters, whereas ID is an ammeter. So I am going to place a voltmeter between the two terminals, gate and the source, and that I am going to name it as VGS. Again, a separate voltmeter will be connected between the drain and the source, and that will be named as a VDS. So what we are going to do, we are going to vary this VGG, we are going to vary this source voltage such that this VGS will be maintained at some constant value. Initially, let VGS be set to 0 volts. Starting VGS 0 volts baro hage na set ಮಾಡಿ. If there is any variations, I am going to make sure that this voltmeter will be showing 0 volts. After that, we are going to vary this VDD in such a way that VDS will be set to some voltage levels. Ad corresponding ID values na ಏನು ಮಾಡ್ತೀವಿ note down ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. So characteristics ಅಂತ ಬಂದಾಗ we are going to draw VDS, that is drain to source voltage, across the x axis and the drain current ID across the y axis. After this, we are going to get a set of curves. Set of curves ನಮಗೆ ಈ ತರ ಸಿಗುತ್ತೆ. So this is the drain to source voltage which is measured in volts, and this is the drain current which is measured in milliamps. Very first point, this is VGS is set to 0 volts. Then we are going to vary this VGS, or we are going to vary this VGG and set that VGS to minus 1 volts, VGS to minus 2 volts, VGS to minus 3 volts. ಈ ಥರ ಬೇರೆ ಬೇರೆ VGS values ಗೆ we keep on varying this VDS and note down the values of ID, and then we are going to draw a graph. ಈ graph ಅಲ್ಲಿ ನೋಡಿದಾಗ we will be having 3 different regions, and the very first region, this is the region which will be called as the ohmic region, and this is the region which will be called as the saturation region or the pinch off region ಅಂತನೂ ಹೇಳ್ಬೋದು, and this is the region which will be called as the breakdown region. So these are the 3 different regions what we have to understand when it comes to the drain characteristics, that is the ohmic region, saturation region and the breakdown region. Let us draw a separate graph. Before that, the maximum current which is reached when the VGS is equal to 0, adana ನಾವು IDSS ಅಂತ ಕರಿತೀವಿ. IDSS is nothing but drain to source saturation current. This is the maximum current which is attained, which is reached in the n channel JFET when VGS is equal to 0 volts. Let me draw this different regions separately and try to understand that properly. So this is a graph of VDS which is measured in volts and ID which is measured in milliamps. I'll be having 3 different regions. This region will be called as, let me call this as 1, this region will be called as 2, and above this will be called as 3. First one, ohmic region. So what is this ohmic region? It is a region in which the JFET will be behaving like a resistor. Resistor tara behave agutte anta helidre the current ID will be varying in accordance with the drain to source voltage. So ID will be varying in proportion with the drain to source voltage. So I am going to get a straight line. Adanna ನಾವು ohmic region ಅಂತ ಕರಿತೀವಿ. Apart from this region, ಈ curve ಇದೆಯಲ್ಲ, so ಇನ್ನೂನು ನಾವು voltage ನ VDD ನ vary ಮಾಡ್ತಾ ಹೋದಷ್ಟು ಏನಾಗುತ್ತೆ, the current starts increasing very slowly. ತುಂಬಾ ಕಡಿಮೆ ಫೇಸ್ ಅಲ್ಲಿ ನನಗೆ ಕರೆಂಟ್ ಏನಾಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Why is that so? As I have already told you in the earlier session, ನಾನು ಈ ವೋಲ್ಟೇಜ್ ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಹೋದಷ್ಟು the width of the depletion region ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. As and when the width of the depletion region starts increasing, the channel space available for the charge carriers to flow from one terminal to the other terminal ಏನಾಗುತ್ತೆ, reduce ಆಗ್ತಾ ಹೋಗುತ್ತೆ, which in turn reduces the current. So as and when I keep on increasing the voltage, the current starts decreasing ಸ್ಲೋಲಿ ಅದನ್ನು ನಾವು ಈ ಕರ್ವ್ ಅಂತ ತಗೋಬೋದು. ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ದಿಸ್ ಸ್ಯಾಚುರೇಷನ್ ರೀಜನ್, ಈ ಸ್ಯಾಚುರೇಷನ್ ರೀಜನ್ ಅಂತಂದರೆ ಏನು, ದಿಸ್ VDS increase ಮಾಡ್ತಾ ಹೋದಷ್ಟು there comes a point when both the depletion region will be touching each other. ಎರಡೂ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಟಚ್ ಆಗ್ತಾ ಇದೆ ಅಂತಂದರೆ ದೇರ್ ಇಸ್ ನೋ ಸ್ಪೇಸ್ ಅವೈಲೇಬಲ್ ಫಾರ್ ದ ಚಾರ್ಜ್ ಕ್ಯಾರಿಯರ್ಸ್ ಟು ಫ್ಲೋ ಫ್ರಮ್ ಸೋರ್ಸ್ ಟು ಡ್ರೈನ್. ಸೊ ಕರೆಂಟ್ ಅವಾಗ ಎಷ್ಟಿತ್ತೋ ಅಷ್ಟಕ್ಕೆ ನಿಂತ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಐ ವಿಲ್ ಬಿ ಗೆಟಿಂಗ್ ಅ ಕಾನ್ಸ್ಟೆಂಟ್ ಕರೆಂಟ್ ಆ್ಯಂಡ್ ದಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಕರೆಂಟ್ ವಿಲ್ ಬಿ ನೇಮ್ಡ್ ಆಸ್ IDSS, which is nothing but drain to source saturation current. After the saturation region, we will be getting a region what is called as the breakdown region. So what is this breakdown region? Breakdown region is nothing but a region in which the current increases very rapidly. ನಾನು ಈ ಸ್ಯಾಚುರೇಷನ್ ರೀಜನ್ ಆದಮೇಲೆ ಇನ್ನು ವೋಲ್ಟೇಜ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಹೋದಷ್ಟು ದ ಕರೆಂಟ್ ಇನ್ಕ್ರೀಸಸ್ ಟು ಅ ಹೈಯರ್ ಎಕ್ಸ್ಟೆಂಟ್ ಡ್ಯೂ ಟು ದ ಎಫೆಕ್ಟ್ ವಾಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ದ ಅವಲಾಂಚೆ ಎಫೆಕ್ಟ್. ಅವಲಾಂಚೆ ಎಫೆಕ್ಟ್ ನಾವು ಆಲ್ರೆಡಿ ನೋಡಿದ್ದೀವಿ ಇನ್ನು ಫಸ್ಟ್ ಇಯರ್. ವಾಟ್ ಇಸ್ ದಿಸ್ ಅವಲಾಂಚೆ ಎಫೆಕ್ಟ್? ಇನಿಷಿಯಲಿ ಆಸ್ ಸೂನ್ ಆಸ್ ಐ ಅಪ್ಲೈ ಅನ್ ಎಕ್ಸ್ಟರ್ನಲ್ ವೋಲ್ಟೇಜ್, if we consider there are 5 free electrons, those 5 free electrons starts moving from one place to another place. While moving, they'll find 5 different atoms in which 5 extra electrons will be released. So at this point, I'll be having 10 number of free electrons. All those 10 free electrons will again collide with the new 10 atoms, releasing another 10 electrons. So in the meanwhile, the number of free electrons keeps on increasing, which in turn increases the current in a rapid manner. So our effect we are going to call it as the avalanche effect. So in the drain characteristics, we have to understand 3 different regions. One is the ohmic region, in which the JFET will be behaving like a resistor. Saturation region, in which the drain current will be 0 because the depletion region of the 2 junctions will be touching each other. And the third is the breakdown region, which is due to the avalanche effect. This saturation region is also called as the pinch off region, and the voltage at which this IDSS maintains at constant value is called as the pinch off voltage, which will be represented by VP, that is pinch off voltage. And this drain characteristics can be understood easily with the equation what is called as Shockley's effect, Shockley's equation, Shockley's equation, which will be given by, let me write here, ID equals IDSS of 1 minus VGS by VP whole square. So this is the relationship between the drain current and the gate to source voltage, which is called as Shockley's equation. This is all about the drain characteristics of n channel JFET. Let us now try to understand the transfer characteristics of n channel JFET. Transfer characteristics are nothing but the curves which gives the relationship between the gate to source voltage and the drain current, keeping VDS constant. So this is the curve, VGS in volts, ID in milliamps. Initially VDS will be set to 4 volts. Then by varying this VGG, we are going to set this VGS to different voltages. Accordingly, we are going to measure ID, that is the drain current. Then we are going to get a curve like this. And again this will be behaving the same equation, that is the Shockley's equation, which will be given by ID equals IDSS of 1 minus VGS by VP whole square. So this is all about the characteristics of n channel JFET. Drain characteristics antandre it is the set of curves which gives the relationship between VDS and ID, keeping VGS constant. Transfer characteristics ಅಂತ ಹೇಳಿದ್ರೆ it is the set of curves which gives the relationship between VGS and ID, keeping VDS constant, where VGS will be taken on the x-axis and ID will be taken on the y-axis. Now let us try to understand some of the definitions, what we are going to call as the parameters of JFET. These parameters are very important from the examination point of view. Along with that, it is very important in order to use this JFET for any of the design of the circuits. Very first parameter. Characteristics Allah. Now we are going to see what is called as the Jfet parameters. So the very first parameter is DC drain resistance, RD, which will be represented by RD. So DC drain resistance is a ohmic resistance which is given by the ratio of drain to source voltage to the drain current ID, keeping VGS constant. It is the ohmic resistance which is given by the ratio of drain to source voltage to the drain current, keeping VGS constant. It is measured in ohms. Coming to the next parameter, that is AC drain resistance. AC drain resistance RD, small letter RD. It is also called as the dynamic drain resistance, which is given by the ratio of corresponding change in VDS, a small change in VDS to the corresponding change in ID, keeping VGS constant. It is the ratio of small change in drain to source voltage to the corresponding change in drain current, keeping VGS constant. Even this will be measured in ohms. The next parameter is transconductance. Transconductance, which is represented by Gm. So what is this transconductance? Transconductance, this is also called as forward transconductance. It is nothing but the ratio of small change in the drain current to the corresponding change in the gate to source voltage, keeping the drain to source voltage constant. Since transconductance, conductance is nothing but the reciprocal of resistance. Resistance ge unit in ohms. Since this is the reciprocal of resistance, the unit for this is Siemens. Adana now S in the represent mate. So transconductance, which is also called as the forward transconductance, is nothing but the ratio of small change in the drain current to the corresponding change in the gate to source voltage, keeping drain to source voltage constant. And the last parameter is amplification factor. Amplification factor, which is represented by mu. Mu is nothing but the ratio of small change in VDS to the corresponding change in VGS, keeping ID constant, and this is not having any kind of unit. So amplification factor represented by mu is the ratio of small change in drain to source voltage to the corresponding change in gate to source voltage, keeping the drain current constant. So these are the four important parameters which is very important. Now let us try to understand the relationship between the amplification factor and transconductance and the drain resistance. Let me write these formulas on one side. DC drain resistance RD is equal to VDS by ID, small letter RD, delta VDS, that is AC drain resistance, delta VDS by delta ID, transconductance GM, delta ID divided by delta VGS, amplification factor mu, delta VDS divided by delta VGS. So these are the four different parameters. Now let us try to understand the relationship between mu, RD and Gm. Mu is amplification factor, RD AC drain resistance, Gm transconductance. We know that mu is equal to delta VDS by delta VGS. We have already derived that. We have already got that. So let us multiply both the numerator and denominator by delta ID. delta ID ಇಂದ both numerator and denominator ನ multiply ಮಾಡಿ. After that delta VDS by delta ID. What is that? Delta VDS by delta ID is nothing but RD. So mu is equal to, in this space I am going to write RD and delta ID into delta VGS. Delta ID divided by delta VGS is given by GM. So this itself is the relationship between mu, that is the amplification factor, AC drain resistance and the transconductance. Even this is most frequently asked. So this is all about the characteristics of n-channel JFET and different JFET parameters, also the relationship between mu, RD and GM. So now as usual, let us try to see what are the questions asked in these particular topics. Define pinch off voltage. It is asked for 1 marks. So it is the voltage at which the drain current will be equal to 0 anta barre saku. That itself is pinch off voltage. Derive the relation mu is equal to GM into RD. So this particular derivation itself you have to write, and that is for 3 marks. It is very simple, right? Bari ee sidal expressions na barkoli, ad related mu na tagondu multiply both numerator and denominator by delta ID bardu write this particular relationship, which will be carrying 3 marks. Then define the term transconductance, define the term amplification factor. All those parameters can be asked separately, which will be carrying 1 marks. Apart from that, expand GFET, which is very simple, right? Adanu 1 marks keltare. Name the charge carriers in n-channel JFET. Name the charge carriers anta helidaga majority charge carriers. N-channel nalli electrons will be flowing from source to drain. So electrons are the charge carriers in n-channel. Ade p-channel enu anta kelidre holes are the charge carriers in p-channel JFET. Again, compare between FET and BJT. This is most frequently asked. At the last, explain the working of n-channel JFET anta heltare. p-channel JFET kelode illa, n-channel JFET the construction working matra keltare. So this particular chapter will be having a weightage of 4 marks, 1 from the 1 mark question and 1 from the 3 mark question. So this is the end of this session. In the next session I will be coming with some of the problems, simple problems. Ee formula gottire namage aaramagi problems na solve madbodu. So let's end up this session at this stage. I will be coming soon with the next session. Until then, take care. Bye bye.